Hello everyone. In this lesson we'll talk about the rate of change. And a rate of change is a rate that describes how one quantity changes in relation to another quantity. So if x is independent variable and y is dependent variable, then the rate of change will be the change in y over the change in x. When it comes to talk about the rate of change, we are looking at two main things: average rate of change and instantaneous rate of change. Let's first focus on the average rate of change. So in order to find the average rate of change, we are going to do it either algebraically or graphically. Algebraically, it's basically the slope. So it's the difference of y values over the difference of x values. Now, graphically, that means average rate of change is basically the slope of the secant. So what is a secant? If I have 2 points here, the line that passes through these 2 points is called a secant. And the slope of that secant, is the average rate of change. Let's try to find the average rate of change for these questions. So if I have fx equal x squared minus 2x over an interval 1 to 3, I need to find the rate of change, which is equal to, or average rate of change. So average rate of change will be equal to delta y over delta x. Since I don't have y, I will say delta fx over delta x, which is equal. Now I need to find f3 and f1. f3 will be 3 squared minus 2 by 3. 1 will be 1 squared minus 2 by 1. That's 9 minus 6, which is a 3. 1 minus 2 is negative 1. So that's f3 minus f1 over 3 minus 1, which is equal 3 minus negative 1 over 2. And that's 4 over 2, which is equal to 2. So that's my average rate of change for this function over 1 to 3. Now let's look at this question. A rock is tossed upward from a cliff that is 120 above the water. The height of the rock above the water is modeled by the equation ht equal negative 5t squared plus 10t plus 120, where h is the height on meter and t is the time in second. Calculate the average rate of change in height during the first 3 seconds. What does that mean? The first 3 seconds, we are talking about from 0 all the way to 3. From the time we start tossing the rock, which is was 0 at that time, until 3 seconds. First of all, average rate of change will be equal h3 minus h0 over 3 minus 0. Now, h3 equal to negative 5, 3 squared plus 10 by 3 plus 120. And that's basically equal to 105. And h0 equal negative 5, 0 squared plus 10 by 0 plus 120. And that's 120. So 105 minus 120 over 3. And that's equal to 15. Negative 15 over 3, that's equal to negative 5. So the rate of change here is equal to negative 5. Now we will talk about the second one, which is the instantaneous rate of change. So instantaneous rate of change is the rate of change for any function at a specific value of the independent variable x. It can be determined by finding the average rate of change, but at very, very small value. And we can calculate it by using this formula, which is fa plus h minus fa over h. So graphically, it's the slope of the tangent line. So if you look here, here's the graph. I have this point here. If I draw a tangent line, the tangent line is just touching the graph at that particular point. The slope of this tangent line is going to be your instantaneous rate of change. So let's look at this question here. A ball is kicked into the air. Its height is modeled by this equation, and they want us to estimate the instantaneous rate of change in the ball's height at 3 seconds. Here I don't have an interval. I have a specific point, which is a 3. So instantaneous rate of change, that means it's the instantaneous rate of change, which is the slope of the tangent. So we know it's going to be the slope of the tangent, which is going to be, again, we are going to use this formula, fa plus h minus fa over h. A in this case is a 3, so it will be f3 plus h minus f3 over h. So now f3 is basically equal to negative 5 times 3 squared plus 3 times 3 plus 65, and that's equal to 29. Now I need to find 3 plus h, f3 plus h. f3 plus h is equal to negative 5 by 3 plus h squared plus 3 by 3 plus h plus 65. And now you can simplify that by expanding the square, so it's going to be negative 5, 9 plus 6h plus h squared plus 9 plus 3h plus 65. You can simplify it more. That would be negative 45 minus 30h plus minus 5h squared plus 9 plus 3h plus 65. By collecting the like terms, it will be negative 5h squared minus 27h plus 29. Now you go here and put this all together. So it will be negative 5h squared minus 27h plus 29 and minus 29, because I do have minus here, over h. Now you can see that these two can cross out each other. So take h as a common factor. That will be, or you can say negative 5h minus 27 over h. These two will cross out each other. Now you will say, as h approaches 0, because we want h to be very small, then instantaneous rate of change will be negative 5 by 0 minus 27, and that's equal negative 27. That's going to be my instantaneous rate of change. Now let's try this question. The displacement in meters of a moving particle is given by the formula dt equal 5t minus t squared. Find the average velocity from 1 to 3. So he gave me an interval. So it could be t between 1 and 3, or you can say 1 to 3, open interval here. Now, average velocity, since it's an interval, we know that this is going to be an average rate of change. If it is instantaneous rate of change, he will give you a specific point. Will be equal f3, oh sorry, not f in this case, it's d. So d3 minus d1 over 3 minus 1. And that's equal to, so you need to find d3, 5 by 3 minus 3 squared, which is equal 15 minus 9. And that's going to be equal to 6. And d1, 5 by 1 minus 1 squared, so it will be 4. So it will be 6 minus 4 over 2. That's going to be 2 over 2, which is 1. That's my average rate of change for the interval from 1 to 3. And since we are talking about velocity, you'll say meter per second. Estimate the instantaneous rate of change at t equal 4. Then instantaneous rate of change is basically the slope of the tangent. In average rate of change is the slope of the secant. You need to remember that. D h plus 4 minus d4 over h, which is equal. So now d4 will be equal to 5 by 4 minus 4 squared, which is equal to 20 minus 16. That's equal to 4. Okay, so now I know that there is minus 4 here and there is an h here. Now we need to find d, h plus 4, 5 d, h plus 4 minus h plus 4 squared, 5h plus 20 minus h squared plus 8h plus 16. That's going to be equal 5h plus 20 minus h squared minus 8h minus 16. Now, in a simplest form, negative h squared minus 3h, and then plus 4. So you go here, negative h squared minus 3h plus 4. Again, these two would cross out each other, and we'll take h as a common factor. Negative h minus 3 over h. That's going to be negative h minus 3. So you are going to say, as h approaches 0, instantaneous rate of change will approach what? Negative 3. Because negative 0 minus 3 is negative 3. That's going to be my instantaneous rate of change. Now for this question, we need to find the equation of the tangent at the given point. Now when we think about the equation of the tangent, we will think right away about the instantaneous rate of change, because we know that the slope of the tangent is the instantaneous rate of change. And we know in order to write an equation of a line, it has to be written as y equal mx plus b. M is basically the slope of the tangent, and the slope of the tangent is going to be instantaneous rate of change. So what we should do, we need to find the instantaneous rate of change of the function at x equal to f2 plus h minus f2 over h. Now f2 equal to 7 minus 2 squared, and that's equal to 3. And f2 plus h will be equal to 7 minus 2 plus h squared. 7 minus 4 plus 4h plus h squared. That's 7 minus 4h minus h squared. 3 minus 4h minus h squared. Now we go here and substitute 3 minus 4h minus h squared minus 3 over h. These two would cross out each other, and I'll take h as a common factor. Again, they will cross out each other. So now as h approaches 0, instantaneous rate of change will be equal to negative 4 minus 0. That's equal negative 4. That's my slope of the tangent. So now the point is 2 and 3, which is x and y. So, and the slope is negative 4. So y equal mx plus b. Y is 3, m is negative 4, x is 2, plus b. I need to find b. 3 equal negative 8 plus b. So b equal 3 plus 8, which is equal 11. So my equation equal negative 4x plus 11. That's the equation of the tangent. So now here we are going to find again the equation of the tangent at x equal 1. So we're going to do again slope of the tangent is the instantaneous rate of change, which is equal f1 plus h minus f1 over h. And now we are going to find f1, which is 1 cube minus 12 by 1. That's equal to negative 11. Now we need also to find f1 plus h, which is equal 1 plus h cube minus 12, 1 plus h. Now 1 plus h cube, you can do it in many different ways. You can do it by using the formula, or if you can't remember the formula, you can do it like this. So it will be 1 squared plus 2h plus h squared. Okay, that's 1. Multiply 1 plus h, and then you multiply them. So 1 plus 2h plus h squared plus h plus 2h squared plus h cubed. Can put them in order. 3h squared plus 3h plus 1. So that's going to be my first part. So h cubed plus 3h squared plus 3h plus 1. And then minus 12 minus 12h. So it will be h cubed plus 3h squared minus 9h minus 11. You go here, h cubed plus 3h squared minus 9h minus 11, then minus negative 11, which is positive 11. That's, these two would cross out over h. Taking h as a common factor, Now, as h approaches 0, instantaneous rate of change, or the slope, will be equal to 0 squared plus 3 by 0 minus 9, which is equal negative 9. That's going to be my slope. Now, since I know that my point is 1, negative 11, and my slope is negative 9, so the equation will be y equal mx plus b, negative 11 equal m by negative 9 by 1 plus b, so b equal negative 11 plus 9, which is equal negative 2. So my equation will be equal negative 9x minus 2. So that's everything, guys, about today's lesson. Please let me know if you have any question, and see you next time. Bye bye.